Alrighty. Now we're ready to begin. So, simplifying rational expressions. Okay. It is frozen. There we go. Sorry about that. Okay. So, we're going to look at simplifying, then we're going to look at adding, subtracting, and then multiplying and dividing. Okay, so we want to go through all of the operations here before the end of the day. All right, so let's see how we do here. So, the directions for these kinds of problems, the directions that you see will be simple, right? It just says, the directions say to simplify. All right? That can mean many different things in many different situations in math. So we need to kind of like interpret what it means for us to do when we see that, right? So for our first problem here, start pretty simple. What would simplify mean in this situation? What can we maybe do here? Any ideas? What's that? Okay, so we're going to use the degrees to see, we see here that there's a common factor, right? We can actually factor out a common factor there. Since we have an x to the third and an x to the second, that means we can say, aha, if we take out an x squared here, we have this. Right, so factoring out an x squared. And with that factoring, then, what can we do to continue to simplify? Take out the x plus 1, right? Those x plus 1s cancel. Now, just because there's a greatest common factor does not mean we'll then be able to cancel out with the numerator and denominator. It doesn't always happen that way, right? Sometimes we'll factor out a GCF, like we did here, and it will not cancel with the numerator and denominator, in which case you're kind of stuck. You're done. You know, you can't go on anymore. But here those cancel, and so we're left with just x squared. Okay? And again, if we want to be kind of like, maybe you could even call it pedantic, I guess, but I will put, okay, that as well. Okay, because x is not equal to negative 1, right? And the reason why I put that there is, again, because for this, right, we're saying that this is equal to this, which is then equal to this, okay? But our final answer here is not exactly equal to our original problem. Here, if I plug in a negative 1, I'm going to get 0 over 0. Here, if I plug in a negative 1, I get 1. So I don't get the same thing. And so we want to say that these two things are equal everywhere, but at x equals negative 1. Okay? Yeah. I'm not going to take points off if you don't do it, but I do think it's important to understand, you know, when you see it, why you see it. Okay? Let's try another one, though. And actually, I'm going to have you guys try this one, I think. Okay, so you all try this one. Okay, so try this one. Be like 30 more seconds here. 30 more seconds. Exactly. Flashbacks to earlier today.
I'm gonna flashback, sure. Do that.
Good stuff.
What'd you get on your SAT?
My SAT was a different test than the one that you took, so it really won't be comparing apples to apples. But I'll be happy to tell you the score, but it doesn't. It's not comparing. It's not the same test that you guys.
Because you get points off for guessing, right?
You lose a quarter point if you answered incorrectly. You would lose no points if you just left it blank, and you got a full point if you got it right.
It's really stupid. Because everyone, when they don't know an answer, just fill it in the same answer.
Well, I guess my as to discourage guessing, because on the other hand, if you guess and get it right, then you're not really showing any understanding at all. You're just showing that you could guess that particular question well.
Yeah, but insecure students might not, you know.
Sure. So it was a gamble about whether to answer the question or whether to leave it blank.
What did you get on the SAT though? We'll give you like a bonus, like 50 points.
Thanks. So my SAT, I got, it was like 15.
Wait, that's already good.
1530, I want to say. Yeah.
70 points off from a perfect score.
Yep. And I regularly scored better in my verbal than I did in my, which is what they call the reading one. I regularly scored better in my verbal than my math.
That's ridiculous.
Yeah.
Why aren't you at Harvard?
Why wasn't I at Harvard? I don't know.
Yeah, why did
Because it doesn't, just because one SAT score doesn't really help you do that. What's that? Maryland.
The national average is 980.
Yeah.
That's the national average?
Yeah.
We're just basically I got above that. That's not Springfield's average though.
Yeah, probably not.
Way higher.
But again, my test was different. So for example, my test only went up to geometry. Your test goes up to algebra 2, right? My test had like analogies on it. Your test doesn't have analogies on it. Some people thought analogies were a difficult portion they got rid of.
So like now, is it like better to guess or is it better to not?
Now you might as well. You lose nothing. By guessing.
You guess algebra, you get points.
Okay, back on track here though.
You don't hear anyone about getting just multiply by 3. But it was like 3/4 pi.
There's our final answer. Questions on that? Pretty easy. Okay, let's keep going then. Oh wait, question, yes.
Why do you write x can't be equal to -5, but not x can't be equal to +5?
Okay, right. I see what you're saying. So I don't continue to write I don't write x not equal to +5 because that domain restriction stays relevant throughout the whole problem. Here, right, x equal to -5 is a problem. Here, x equal to -5 is not a problem. So we want to include that.
When you graph it, is x equals 5 still a whole though?
So +5 would not be a whole. -5 would be a whole.
Is the +5 an asymptote?
Yeah. And again, you can kind of see that thinking. So a whole, the idea about a whole is where, like, a whole, if you imagine then a function with that hole filled in, those two functions, well, the one with the hole, the one without the hole, okay, they're they're the same at all but one point. And that's exactly what we're saying here, isn't it? This is the exact same as this at all but this one point. So that's kind of like the idea of the whole there too, sewn up. And we're going to get to those two discontinuities a little bit later in this unit that we're going to be moving into. So I'm glad you guys remember that. Yes. Okay, let's take a look now at adding and subtracting. We'll start out with easy adding, subtracting, and then we'll get some more challenging ones. But challenging is only a matter of degree, probably not, an actual. Might not be too bad if you remember from your algebra 2. Okay, so simplify. Again, will be our directions. Hello, gentlemen. Welcome. Hola. I know just what you guys wanted to do after taking that SAT was more math, but here you go. All right, so we'll start with a very easy one. Okay, so can we combine these fractions? Yes. Why? Common denominators, right? So the idea, which I didn't really get to hit on here at the warm-up, right? Adding and subtracting requires that we have common denominators. And it's for a similar kind of reason for when we add like terms, right? What are common denominators but really just like terms, right? When you start with something like, or when you had, I don't know, we had what, 3/5 and -8/7, right, earlier in the warm-up. 3/5 and 8/7, those are two different kinds of quantities, right? Fifths and sevenths aren't the same, so you can't add them together. Instead, we rewrite them in an equivalent form, right? But now we talk about the same units. We get them in the same units. 21/35, 40/35, and then you can combine them because they are like terms. Multiplication, it's not so important to have like terms, right? You can multiply 3x times 2y, no problem. But you cannot do 3x plus 2y. They're not like terms. Okay? Same idea is happening when we add fractions and need those common denominators. So anyway, we have common denominators here. I'm going to take an extra step here that you probably don't write out, but I'm going to do it just because I want to kind of make a point. Okay? That 4x minus 2, that quantity is being subtracted. The minus sign is in front of the fraction, so it is the entire quantity that subtracts there, which means the minus distributes. And we end up with 5x plus 1 minus 4x plus 2 over x squared minus 9. So please be careful when you're subtracting those fractions like that. The minus distributes to the numerator, or the denominator if you like. And so I'll put this all together here, and we'll get what? X plus 3 over x squared minus 9. Right, so we've added, but can we still simplify further? Yes, the denominator factors x plus 3, x minus 3. And so those cancel. We're left with 1 over x minus 3 as our final answer. And I'm going to put comma x not equal to negative 3 there.
So if there's something just on the bottom by itself, you just put 1 over the top.
When you cancel, the canceling is division. When you divide something by itself, you're left with a 1. So there it is. Questions on any of that? Any other questions, I should say? Other questions? All right. Let me give you guys one to try here. Again, I'll give you a nice one to try. X over x plus 1 minus 3x plus 2 over x plus 1. Okay, so you guys go ahead and try this one here, number 2. Okay, try that one. Okay, so give that one a try. Again, that was nice. I gave you a common denominator already, so. You're welcome. All right, 30 more seconds here. 30 more seconds. Try and get it done in 30 more seconds here. There's what you should have gotten. -2. Just -2. And of course, that's for x values not equal to -1, right? So those are equal, that is simplified down just to -2, as long as x is not equal to -1. Okay? Bless you. Questions on any of that? All right, get on with it, Mr. Wood. Here we go. All right, so that was simplifying, right? So that's something we want to be able to do, and also adding and subtracting. But of course, we won't always have common denominators, will we? So let's continue on with our simplifying here. And let's instead subtract here. Subtract these. Can we subtract these two fractions as they're written? No, because they don't have common denominators, right? They are not like terms. We can't combine them. So we have to make common denominators here. So if you remember, like in what we did in the warm-up, right? We had, for example, 3/5 and 8/7, right? So the 3/5, its denominator was missing a 7, so we multiply by 7, right? The 8/7, its denominator was missing a 5, so we multiply both sides, or multiply it by 5. So here, right, for these to be common denominators, this denominator needs an x plus 3 in it. This denominator needs a 2x minus 3 in it. So we're going to multiply by those missing pieces. So that x plus 3 will multiply by 2x minus 3 over 2x minus 3. And this 2x minus 3 will multiply by x plus 3 over x plus 3. Like so. Okay. And then we have to multiply the numerators out at least. So x squared plus what? 5x plus 6. I'm going to leave my denominator in the factored form. And again, you can skip some steps here if you like. I am writing it out because it's notes. Okay, you can skip steps if you like. All right. We have the minus sign in front of the fraction here, which means that minus sign distributes to the 8x and to the minus 12. Right now we have a common denominator, so we can distribute the minus sign to the 8x and minus 12, and we're left with x squared, 5x minus 8x, negative 3x, 6 minus a negative 12, plus 18, all over x plus 3. And 2x minus 3. So, does it simplify any further? Does it simplify any further here? Can we factor any further? So, yeah, Lee? X minus 6, x plus 3, that would add to negative 3x, but that would multiply by negative 18. We need a positive 18.
Negative 6 and plus 3.
Negative 6 and plus 3, yeah, that's what we're saying there. And it won't multiply. It'll give you the negative 3 in the middle term, but it won't give you a positive 18. It won't give you a positive 18. So does this thing factor? No. Nope, we're done here. Okay, that's it. That's as good as we can get. Okay. Do you need to multiply out the denominator? Nah. Okay, nah. In fact, I wouldn't, because if that numerator did simplify, you'd want the denominator to stay unfactored, or factored, I should say, so that way you can, cancel things out. So in other words, get a common denominator by multiplying each denominator by the denominators of the other fractions. Get a common denominator by multiplying each denominator by the denominators of the other fractions. Okay. Get a common denominator by multiplying each denominator by the denominators of the other fractions. That's kind of like the brute force method of getting a common denominator, right? I'll show you how we can use strategy in a little bit. But first, I'm going to give you one to try. Here's one for you. Simplify. 3 over x plus 1 plus 5 over x minus 1. Okay, go ahead and simplify that. Yep, okay, right there. One sec. So if you multiply the top and bottom by negative 1, you have negative x minus 1. You have positive x minus 1. Okay, so yes, sadly. You have a volunteer that wants to give us their answer. Joshua, go for it.
Ax plus 2 divided by x squared minus 1.
Okay, so yeah. A couple different ways you could have your final answer here. There's not really like one necessarily better than the other. So you can have the 8x plus 2. I left it factored, x minus 1 over x, or times x plus 1, but the x squared minus 1 is no problem there. You could also, you can recognize there's a 2 you can take out there. 2 times the quantity 4x plus 1. Is that necessary? No. Is it more simple? Maybe. I don't know, but something like that. Okay, would be your answers there. Questions on any of that? All right. Let's keep rolling then. We're going to do one more adding and subtracting. Okay, so let me do that here real quick. Okay. Whoops, I'm way off the screen there. Sorry about that. Okay, there we go. So we're going to add these two fractions together. Okay. And they're not common denominators, so we could take our denominator here, multiply it over to here, right? Take our denominator here, the x squared plus 6x plus 9, multiply it over to here. All right? But, and that would work. That would work. It gets kind of yucky though, right? Because we're doing like a trinomial becomes a binomial, and then the binomial becomes a trinomial too. It's just like ugh, lots of multiplying and stuff like that. I guess that's, well, anyway. Potentially it's yucky, right? However, let's take a look here. what can we do with this denominator before we start, kind of, what can this denominator do here? Yeah, we can factor out a 5x, and that leaves us then with x plus 3. And what about this other denominator? X plus 3 times x plus 3, right? It factors too. Okay. I didn't leave myself much space again this time, but oh well. I did it again to myself. Now, upon first glance, right, these denominators had nothing in common. But when we factored, we now see they do have something in common. What do they both have? An x plus 3, right? So, but then they also are not the same, right? So they both have one x plus 3. This denominator, though, what's it missing? Another x plus 3, right? It's got one, and you need another one. What is this denominator missing? The 5x, right? So we'll multiply this one by the 5x over the 5x. We'll multiply this one by an x plus 3, and then an x plus 3. Okay, I didn't leave myself much space there, but you can kind of see it. Okay. So rather than having to multiply by the entire denominator, we only need to add one little piece in, and it makes it a little bit nicer for the math. And so we end up then with we end up with that. Okay. And I guess since we're doing x plus 3 times x plus 3, I could rewrite that if I wanted to. Since we're multiplying x plus 3 by itself, we could say that's 5x times x plus 3 squared, if we wanted to. But either one of those is fine. Right there. Okay, either one's fine. All right, so, yes, Jess.
If the number was like 55 on top, could you simplify with the 5x on the bottom?
So, good question. Let me, so the question is, right, if we had, let's say hypothetically we had this. Something like that, okay? Question is, can we simplify the 55 and the 5? Right, yeah, it's kind of a weird situation here. I'm trying to think if I could, like, help you see why here. Let me try and put it to you this way. Okay, simplify, like, so do you see it's kind of the same idea, right? We have like this plus something else, right? So this plus something, right? And then over, and then this is all one product here, right? 5 times x times the quantity x plus 3 squared, right? So this 5 is like a product. I could put like a little x in here if I wanted to or something, but you get the idea, right?
And if it was multiplication, like on the top instead?
Yeah, if it was 55x times 21, then you'd be good. Yeah, but in a situation, and like just so if you get the idea, but let me just kind of finish my thought here for other people here. So sometimes, right, we run across these things that we want to do and we're not sure if we can do, right? Or we're pretty sure we can do it, but like we want to convince ourselves that we can. And so in a situation like this, right, where it's like maybe a little bit messier, if you can try and like, pull out the important elements and make this a simpler problem, right? We may want to say, well, let's see, 5 plus 3, I know we can add the 5 and the 3, and that makes 8 over 5x. But then it's like, but what if I canceled the 5 out and made that a 1 and a 1? Well, now it's 1 plus 3, 4 over 1x. Is 8 fifths, 8 over 5x, that's the same thing as 4 over 1x. Right? They're not the same. So that means I made a mistake. Either this answer is wrong or this answer is wrong, right? One of these two can't be right. Okay, well, we know this one's right because it's just 5 plus 3 equals 8, so it's got to be, you can't cancel it in front. You can't cancel it in front like that when there's addition. If it's all multiplication, then it does cancel. Okay, so. Good question, though, Jess. Thank you for asking that. All righty. 2 more, then we're done. Okay. Multiplying and dividing. We can make it, folks. We're almost there. Okay, simplify again. X minus 7 over x minus 1 times x squared minus 1 over 3x minus 21. So, right, so we could straight multiply across, right? Because that's what we do when we multiply fractions. You multiply across the top, multiply across the bottom. You could FOIL it out, go from there. However, if you remember back to the warm-up problem, right, we can like cross simplify. So if you can look for common factors in the numerator of one and the denominator of the other, then maybe you can get those to cancel. And in fact, we can factor here, so let's go ahead and do that first. X squared minus 1 is x plus 1 times x minus 1. 3x minus 21 is 3 times x minus 7. Okay. So again, before we multiply, we can go ahead and say, aha, x minus 7, goodbye, right? X minus 1, gone. And so we can say then we've got x plus 1 over 3, or if you like, you could say like 1/3 times the quantity x plus 1 instead, something like that. Right, and then x can't equal what in this case? 7 or positive 1, right. Okay. But again, either of these answers are sufficient there, x plus 1 over 3 or the 1/3 times the quantity x plus 1. Okay. Either of those two are good. So, moral of the story, try to factor / cancel before multiplying. Question? Okay, like this piece right here. So, looking at our original problem, right? Would you agree that, like, for example, if x was 1, we would have a problem because we would have a 0 in our denominator? Okay. Shh. For our final answer, though, if x is 1, do we have that same problem? If I plug in 1 here, so like 1 plus 1 is 2, 2 divided by 3, 2/3. No problem, right? So you see the issue. We're saying this is equal to this. That means they're the same thing. But here, if x is 1, undefined, or more, actually it's going to be indeterminate form, 0 over 0. Shh. Here, you get a number. Okay? So the issue then is saying, we're saying two things are equal when they are not always equal to each other. So how do we fix this, right? Well, this does equal this almost everywhere except when x is 7 or 1. Here, right, 7 and 1 would make us undefined. Here, 7 and 1, no problems. And so we need to say these two things are equal except x not equal to 7 or 1. Does that make sense now? Okay. So, yeah. Go ahead. All right, one more. Last one. Instead of dividing, what? Not cross multiply. Multiply by reciprocal, yeah. Which I guess, in a sense, is like what we would be doing, but yeah. That's true. Okay, so also I'm going to factor simultaneously too, because it's just, why not save on some space here, right? Okay, with factoring and multiplying by the reciprocal, what cancels here? X minus 1 and an x minus 1. X squared plus 1 and x squared plus 1. And we're left with then 3 times x minus 1 over x times x plus 2. And again, in this case, we lost, that x equals 1 wouldn't work here, right? But it does work here. So we want to exclude x equals 1 there because they're not equal at that x equals 1. Okay. Again, I'm not going to be looking for you guys to put that x not equal to 1 part when you're like writing your answers out and stuff like that on quizzes or tests, but it's going to be an important concept that we kind of understand here.
Do you want us to combine like the 3x minus 1?
You can, but it's not necessary, right? Not necessary. Nope. Because I would, that's debatable. I would say that's debatable about whether that's more simple or not, right? The directions are simplify. Is it more simple to put the 3 together with it or leave it out?
Simple to just not do anything at all?
Well, I mean, I say this certainly looks more complicated than this does, right? This is more simplified than that. So, anyway. All right. Questions on any of this for me here? Okay. So, your homework then will be in the back of the book, okay, and the appendix. So, sorry to those of you that like to use the online one. It's a lot of scrolling, I know, but. Page A46, numbers. $49 to $55, the odds. 63, 65, 69, and 71. Okay, and of course, don't forget there's your TenMarks too that you could be working on as well. Alrighty.
There's no